Okay, so hello everyone. Thank you so much for joining in and listening to this talk. As you can see here, I'm going to talk about the present and the future of Angular with Ivy. Now, a lot of you might not know what Ivy is. A lot of you might already know what it is all about. But throughout this talk, I'll be touching upon a few major intricacies about Ivy, and so that by the end of this talk, hopefully, you will be able to better appreciate what the whole Angular team has done for us for the past 2 to 3 years or so. Let's first address the elephant in the room. What exactly is Ivy? So Ivy is the third generation of Angular's compilation and rendering pipeline. The first generation was called the template compiler, and the second generation was called the view engine. And there were some issues with both the template compiler and the view engine, and that's why the Angular team started to make this whole journey of rewriting the whole compilation and rendering pipeline under the hood without even disrupting the whole developer experience. And so now that Ivy is out there, you still write the exact same code that you used to write in, let's say, Angular 6 or 7 or 8, but you still get quite a lot of things out of Ivy. So I did mention something related to the compilation and rendering pipeline. So what exactly is this pipeline all about? Well, you can think of the Angular part of your whole application as something that can be broken down into two major segments. So there's this ngc that is some sort of a command that triggers the Angular compiler, and the Angular compiler compiles your source files into some sort of a JavaScript that can eventually be rendered onto the browser. But this cannot really independently run on the browser because it depends on quite a lot of things that Angular has to offer to us as well, in the form of these libraries that we use from Angular, like the Angular core and the Angular platform browser and other stuff like that. So these libraries are the things that are called the runtime, right? And so this is the whole pipeline that I'm talking about. Now in case of Ivy, the whole compiler as well as the runtime has been rewritten at the background. Right. So the pipeline is responsible for doing quite a lot of things for us as developers so that we don't have to take care of all these things on our own. And these are a few things like transformation of Angular abstractions, because we as Angular developers are used to writing Angular code. Like we generally write TypeScript classes that are already decorated with these decorators like the ng module decorator, the component decorator, and stuff like that. But this is something that is not really running in the browser for us, right? What the browser actually runs is JavaScript, right? So this whole compilation and rendering pipeline is responsible for doing that. So it does things like creating and manipulating the DOM. It is responsible for data binding and change detection, and it is also responsible for creating CSS and animations, amongst other things. Now, Ivy is also an enabler, and you might have heard quite a lot about this particular statement in the past from a lot of the community members who are like really active in terms of Angular. So when the Angular team started to work on Ivy, they had quite a lot of design goals in mind, and it everything revolved around three major aspects. It was all about optimizability, incrementality, and flexibility. Now, as we already see that from the examples that we see out there, a lot of people have also shared uh, the things that they have noticed after they have migrated to Angular 10 or Angular 9, for instance, that their bundle size has now shrunk quite a bit, right? And so there are quite a lot of reasons for that. One such reason is that, let's say for instance, that this is somehow a visualization of what the rendering engine used to look like in the second generation of the compilation and rendering pipeline, that is the view engine. Now the view engine looked like this one giant big switch statement that used to traverse through the data structure that was generated by the compiler at that time, and then it had basically everything. So all the framework code that was supported by Angular was all present in here. But the way it was created, it was responsible for taking everything that was thrown to it, and then it had to somehow make sense of it and then render things to the DOM. But how it has changed is that now this whole big giant switch statement has now been broken down into smaller, more granular, and more focused sets of functions that your compiled code calls. So all these smaller functions are grouped into some things that are called the IV instruction. So how that works is that this is the template code, for instance, right? So this is the code that gets generated by the compiler. Now, as you can see, this is not something that you write. This is something that the compiler makes sense out of the template or the component that you have written, and it translates it into something that looks like this. And you can see here that it makes calls to a few functions that are prefixed with this theta theta symbol. Now all these functions are these IV instructions, or these IV functions that I'm talking about. So the whole framework itself has now been broken down into smaller and more granular IV instructions like these. Now what it enables us to do is, um, our code gets compiled, and then it gets compiled into something that looks like this. And then whatever functions that the compiled code has that it is calling from the framework are only retained as a part of the final production bundle that gets generated, while the rest of the framework code gets easily tree shaked away. This is like a major breakthrough, because now the framework code itself can now be tree shaken away, and this is one of the factors which eventually results in smaller bundle sizes. And these are all these IV instructions that I was talking about. So every specific feature that we have in Angular, let's say if it is about SVGs or content projection or change detection or dependency injection, all these things are now represented by all these smaller and granular pieces of functions that are called the IV instructions. Okay, this is one part. The second part is that with IV, a lot of metadata files that used to get generated before IV, that is in case of the view engine, are now not really required. So this is like some sort of an experiment wherein I'm running the ngc, which is the Angular compiler, and I'm giving it the tsconfig. So it used to generate quite a lot of metadata files. Like as you can see here, it generates for the child component, for instance, it is generating the metadata.json, the ng factory file, the ng factory map file, the ng summary file, and all these different files of sorts. But with IV, everything the that the runtime needs in order to render a component and detect changes on that component at runtime are all present in just one file, and so we don't really need all these additional files of sorts. So this is how it looks like when you uh, run the ngc command in case of IV. So this can be considered as the exact same project, but with enable IV set to true. So IV is enabled in this case, and in this case, when you run ngc, which is the Angular compiler, then it just generates two files, which is the component.js file and the component.js.map file. And the component.js file has everything related to the change detection as well as rendering of this component that the Angular runtime actually needs in order to render that. This is great because now, since we don't really have all these metadata files, and the framework code itself can now be tree shaken away, it eventually results in smaller bundles, which is great, right? So I'm not making this up. This is something that is actually true, and here is an example of a source map explorer uh, view that you are seeing here, which is like a tree map size. So what we have done here is this that you see here was taken when the code was when an application which was running Angular 7 was compiled, and so the resultant bundle was of 3.42 MBs, right? But we migrated to Angular 10, and then we created that bundle again, and then that bundle now resultant was of 2.4 MBs, right? So this is like more than 1 MBs of 1 MBs of bundle size that has been removed away, right? Which is great, right? Because it eventually leads to smaller bundles, and then your application loads faster, it requires less bandwidth, and it offers a great user experience as such as well, right? Other thing is that now the locality that was initially implemented in a different way has now been changed as well. So this is like a code that was compiled in terms of the in terms of the view engine, and here it is an of a component that uses ngif structural directive. And with wherever we are referencing ngif, you'll also see references to things like the view container ref and the template ref. Now the view container ref and template ref are the dependencies of ngif. So ngif requires the view container ref and template ref in order to generate itself. Now what you see here is that the template that is using ngif also has some sort of an implementation detail leakage of ngif, right? So it still somehow references the view container ref and template ref, which is not so good, because now if something changes in the app component, even though something doesn't really change in the ngif structural directive, the Angular compiler will still have to compile or recompile that sort of files that might have changed, right? So it doesn't really have that sort of a guarantee that those files won't really change, because here since we have this implementation detail leakage, we cannot really be certain at this point that nothing might have changed in ngf. So whenever anything used to change in a component that used ngif, for instance, it used to trigger some sort of a global compilation in order to make sure that all things are there in place. That's not really the case with Ivy, because now with Ivy, if we compile the same component, then it produces a file that looks something like this. Here as well we are using ngif, but here we are not seeing those references to the view container ref or template ref, right? And now we only refer to any external dependency like ngif, for example in this case, via a very clean public API. So what it means is, if the public API of ngif doesn't really change, the public API here can be considered as that d.ts file, uh, if you think about it from a TypeScript sort of perspective. So if that d.ts file doesn't really change, then we can be sure that the specific building block in Angular might have not changed, and so it doesn't really need to recompile that specific thing. And so if something changes in the app component, then we only need to recompile or rebuild the app component, and the rest of the things can be taken care of by the previous compilation results that we have. So it results in faster compilations, faster bundle sizes, and faster test execution as well. And all of this happens because of these static fields that gets generated to the component, because like this, when we compile the app component, for instance, it attaches this theta cmp static field onto it, right? And so this is great, because now for every specific building block that we have in an Angular application, whenever we compile that specific building block, then it results in attaching one sort of a static field that basically defines everything that the runtime needs in order to, for instance, in case of a component, render that component and detect changes on that component at runtime. Now, all of this is great. I tried to cover most of the things that I wanted to talk about in case of why Ivy was rewritten, like why the whole template, while why the whole compilation and rendering pipeline was rewritten. But I'm pretty sure that I walked through a lot of that quickly. But I'm talking a lot about that in one of a session tomorrow. So please do check that out. I'll be sharing the slide, and the link to that event is right here. So please do check that out. Now, coming back to the design goals, I've quickly talked about the optimizability and incrementality part of it, but this talk is mainly about the flexibility part of it, as to what Ivy brings to the table for us right now, and what it will be able to give us in the near future. So let's talk about that now. But before that, let me shortly introduce myself. My name is Siddharth Ajmera, and I'm a full stack JavaScript developer based out in Sydney, Australia. I'm also a Google developer expert for Angular. I write tech articles from time to time on publications like indepth.dev, and I'm an instructor of Angular and Firebase on platforms like PactPub and Udemy. And just in case you might want to reach out to me, here's my Twitter handle right here. So yeah, come say hi. All right. Now I have broken down this whole talk into two major segments. One talks about the present and one talks about the future. Now I don't really have a lot of time right now, so I'll probably be focusing more towards the future side, and I'll just be representing the one of the aspects about the present of what Ivy brings to the table. So I'll be doing this with the help of an example, that is lazily loading components. So before Ivy came into the picture, we could only lazily load modules, right? So whatever we wanted to load lazily on demand as a separate chunk, we used to use the load children and then use routing somehow in order to load that specific thing lazily. But that was eventually a module, right? What if I just wanted to load a component lazily? Well, that is something that is now possible. So let's see how that can happen. So I have a very simple application out here, and in this application I'm just going to lazily load a GIF component that I have here. Now how this is going to be lazily loaded is that if you see the app module, I don't really have that GIF component added to the declarations array. So it means that this particular component is not registered on the app module. So the app module doesn't really have any prior meaning of the GIF component as such. Right. So how exactly do I load it dynamically and on demand? So I just have a button over here, and I've binded to the click event on that button, and it calls a method called load GIF lazily. And then there is also a div here. This div acts as a host for the component that is going to be loaded dynamically. So I have a template variable here that's called host for lazy component, and then I'm referring to this div via this template variable using the view child decorator. So that's the view child decorator right here, and here is that name of the template variable. And for the view child, I can also pass in an optional second argument, which is this configuration object that we have here. Here I'm passing the read property as view container ref, because from this template variable, I want to read the view container ref. Now I need the view container ref because I'll be using it to dynamically load the component. And then I'm also using a static of true, because that's something that you use if you want to work with some things that you want to get evaluated at runtime, right? So this is what we do. We refer to that host element using the view container ref. We read the view container ref, and then we set it to a property on my app component. The name of that property is vcref. Great. Now let's see what's happening once the user clicks on the button. So once the user clicks on the button, it calls the load GIF lazily method. Let me just open this side by side so that it's a bit more understandable. Okay, so what I'm doing here is in the load GIF lazily method right here, it is an async method because inside I'm calling a dynamic import statement to the GIF component. Now the GIF component is present right here on the exact same parallel path, which is this. So I will be using the dynamic import statement, which is going to return to me a promise, right? Now, in order to unwrap that promise, I'm using the await syntax, and that's why I had to specify the method as an async method. Great. So this is going to return to me the JavaScript module for the GIF component, out of which I'm destructuring out the GIF component. And once I have the GIF component, then I can pass it to the resolve component factory method of the component factory resolver. Now, the component factory resolver is something that I've here injected as a dependency inside the constructor. So I have the component factory resolver here, and I'm calling the resolve component factory on it and passing it the GIF component. This gives me the component factory. So this is the factory that I receive. Now, this factory is something that I'll be passing to the view container refs create component method. So we can call the create component method on the view container ref and then pass it a factory, and that eventually is going to return to us an object inside which we will have a property named instance, which will refer to that component instance that it has created. And I'm aliasing that component instance to a property named component instance, and then on that I can supply the GIF source as an input property, because this GIF component right here also has this input property, which is GIF source. So this is the app component. I'm supplying the GIF source to it once I have the component instance. And with that, let's see what happens. So let me just open this. Um, okay, yeah, I was here. Okay, great. So let me just reload this application. And since I'll be loading this particular component on demand and lazily, it shouldn't be a part of my main bundle anyways, right? Because I have not specified it or registered it on my app module. I have not specified it as a part of the declarations array anyways. So that's why, right? So since I'm using a dynamic import statement, this will be created as a separate chunk by Webpack. So uh, this is something that will then be loaded via this dynamic import statement that I have here. And so you will be seeing a network call that goes on as soon as I click on the button. So let's click on the button. You will see a call was made to the GIF component, and here we have the JavaScript for the GIF component. And as soon as that GIF component is retrieved, then this whole component factory resolver thing and the view container refs create component thing kicks in and eventually returns to us a component instance. And then that component instance is something that is hosted on the host for lazy component right here. So that's what I'm seeing here on the screen, right? This was not really possible prior to Ivy with Angular 8, for instance, if it was running the Vue engine, but it is now possible with Ivy. Great. So this is only one of the examples that I can show for the present. Uh, let's now talk about the future. So the future as well is something that I'll be demonstrating with a few examples. But before talking about anything, I just want to highlight one thing. That one thing is that a lot of developers out there find Angular to have a very steep learning curve because uh, Angular has quite a lot of concepts, to be honest, right? Angular has things like modules, it has components, it has directives, pipes, a lot of moving parts, a lot of building blocks, a lot of things to capture and acquire before you can even render a component as such, right? So that kind of feels intimidating to a lot of developers who are like really new to Angular. And so this is something that probably the Angular team is trying to fix. And so whatever I'll be demonstrating from this point on might basically blow your mind if you have not seen that prior to this talk. So uh, but before that, I need to focus, or I need to highlight one thing. That one thing is that Angular modules are linchpins to Angular applications. What I mean by this is that Angular modules take care of a lot of work that goes on or happens in the background without even us knowing about it. So Angular module takes care of a lot of things like dependency injection and change detection and stuff like that, right? But um, if let's say that we are able to successfully render a component without even using Angular module, then these are a few things that probably won't be happening by default, right? So these are a few things that we will have to take care of on our own. And so with that, let's start with the first example wherein I will be rendering an Angular component from scratch without using an Angular module. So how exactly do we do that? Well, here we have an Angular application, and as you can see inside this Angular application, there are quite a lot of files out here, right? There is this app.module file, and then it all starts with this main.ts file, which essentially is being referred to inside this angular.json file. And there are basically a lot of files, right? But what if you just want to load one component, right? I mean, you wouldn't really need all these things if you just wanted to load, let's say, let's say a heading tag and a button, and something might change in that heading once you click on that button, right? So, how exactly can we achieve such a scenario? Well, this is something that can be done with this. So, here is one such example. Let me just make this full screen. Yeah. Okay, great. So I'm using stack blades here because I really like stack blades, and it's perfect for such use cases. So this is a very simple Angular application. I'll probably not call it an Angular application because it is just rendering one Angular component from scratch, but without using Angular modules. So just like a regular Angular application, you won't really see a lot of those different files like the app module.js, or sorry, app module.ts and angular.json and main.ts, right? There is just four files over here. There is an index.html file that just has an IV tag. Then there is a package.json, and this package.json looks like a regular package.json. It has a few dependencies. The main dependencies that I have here are Angular core, because that's the only thing that I need to depend on right now. uh, I'm still getting these things like rxjs, tslib, and zone.js because these are peer dependencies to Angular core, so I'll probably not be able to get rid of them yet, right? But as you can see, here is only these four dependencies. But if you open up a regular Angular application, then you'll see a lot of these things, like a lot of these things that we generally don't even use, like animations, for instance. We don't really use animations uh, in very simple applications. Anyways, so what exactly is the trick here? Now remember that in one of the previous examples that I said that whenever you compile an Angular component, the compiler adds a few static fields to the Angular component, and this component, these static fields are basically having all the necessary information that Angular runtime needs in order to render a component and detect changes on that component at runtime, right? So that's something that we are going to manually type in, and we are going to do that with the help of uh, a few IV instructions that I was talking about. So these IV instructions are a few functions that I can directly import from Angular core. Most of these functions are prefixed with this theta theta symbol. The reason for that is that Angular team wants to tell you that okay, this is private in nature and you cannot really use it on production applications, on like you cannot use it on production, right? But still, if you are like thrill seekers and you just want to you know make some experiments with it, then sure, go ahead. Anyways, so I'm importing a lot of these functions from Angular core, and then I have a very simple TypeScript class. This class is named IV component. It has a very simple name property and another simple toggle name method. But apart from these two uh, property and methods respectively, it also has two static fields. One of the static field is this theta FAC static field that we can see right here. Let me just zoom this in a bit more. So this theta FAC static field is a function that returns to us an instance of either a token if we pass it a token, or an instance of the component class itself. So this is the theta FAC static field, right? And it is responsible for creating an instance of that component. And then there is also a theta CMP static field that is a result of calling the define component IV instruction. Now the define component is also something that I'm importing from Angular core. Now, this define component IV instruction is called with a JavaScript object, and this JavaScript object has a lot of things like the type and the selector and declarations and variables and constants. But let's not focus on all these right now. Let's purely focus on this template function. The template function is something that is called by uh, called by the Angular runtime when it has to render this component, and it renders this component in two phases or two passes. uh, and that pass or phase is determined by the render flag. Now if the value of render flag is 1, then it can be considered that this is the initialization phase, and if the value is 2, then it can be considered as the change detection phase. So in the initialization phase, what happens is that it is calling a few functions right from Angular core. So element start, element end, for instance. All of these functions are imported from Angular core itself. So you can think of these calls to these specific IV instructions as something that you can see here in the in the comments. So element starts an element which is of type h1, but it is also stored at a zeroth index. So Angular is somehow maintaining some sort of a data structure in the background, and it is storing these specific elements that it is creating on those specific indices. So this line creates an starts an h1 tag. Then this line, which is the text, which is the call to the text function or the text iv instruction, which is now stored at the first index on the data structure, is creating a name property. So here we will be seeing a name, and then element and ends that element, which is h1. So uh, these three function calls are going to eventually create a template that might look something like this. So we have an h1 tag, then there is a name property somehow rendered over here as text, and then the h1 tag ends. Let's move on and talk about the second thing, which is element start button. So here it's starting a button element now, but on that button element I can also listen to the click event. So this is how you will generally write a click event on a button in Angular, right? So this is how it looks like, and then on the click of that button I need to call the toggle name method that I'll be receiving from the context. Now the context is can be considered as the instance of this iv component class. So the instance would eventually have the name property and the toggle name method, because the name property and the toggle name method are something that I'm already having on this component class, these two, right? So yeah, we are binding to the click event on this button, and once the click happens then we are calling the toggle name method. And then there is also a text node on that button. The value of the text node is change name. So this is how it looks like. So there's a button, there's a click event on it, and then the text that we see on the button is change name, and then there is element end which ends the button tag. So end tag, like this, right? And then so this is the initialization phase wherein the whole template initializes, and this is a regular html markup that you generally are used to seeing, right? Then we have the second phase, which is the change detection phase, which is supplied by the render flag value 2. So what happens in this case is it starts with the zeroth index and then it advances by 1. So from 0 it reaches to 1. Now on the first index we have the name, right? So then what it will do is it will interpolate that text with something else. So it then calls the text interpolate one iv instruction. It will pass in a prefix, then the property that needs to be binded to, and then the suffix, and after that it's going to end. So with all that in place, this is how the component gets rendered. So I see an h1 tag here, and then there is also a button, right? Now uh, as we have binded to the click event on the button and we are calling the toggle name, which would eventually toggle the name property from this dot name, whatever it was, to iv or sid. Like it will oscillate between these two values. Great. So let me just click on the button. uh, Now I'm clicking on the button, but the value is not getting changed. That's strange, right? Well, if you think about it, it's not so strange, because here when I said that Angular applications are Angular modules are linchpins to Angular applications, this is exactly what I meant, right? We are not really using Angular modules in order to create this or render this component onto the UI, right? And so a lot of things that we used to get out of the box using Angular modules is something that we won't be getting out of the box, and change detection is one such thing. So that's what's happening over here. um Let me just pull this onto a separate screen. Great. Yeah, so that's exactly what's happening here. We are actually calling the toggle name method, and the toggle name method is also being called, but and the change name method the change name the name property itself is also getting changed, but change detection is not getting triggered. And so in order to detect changes, there is also another IV instruction that we can use, and that is the mark dirty IV instruction. So I can call the mark dirty IV instruction. uh, that's something that I'll be calling right after I have changed the name. So right here, and then I'll pass it the instance of this. And with that, as soon as I save that, let's click on the change name button again. And as you can see, the name changes now, right? And all of this is happening without Angular modules from scratch, right? Now, I mean, I can give you a moment to basically just visualize what just happened, and then you'll probably be able to appreciate how great this is. But I don't really have time, so I'll probably continue. Anyways, so this was the first example. Now there is a challenge with this particular example, though. The challenge here is that this is the sort of code that you're not really used to writing as Angular developers, right? You're not really used to call those specific IV instructions in order to render something. You are just used to typing in that HTML part so that it gets rendered, and then the TypeScript part of it, and everything is taken care of by Angular in the background, right? Now, I also said that this sort of a code is something that gets generated by Angular, right? So if you compile your Angular component, for instance, this is the sort of code that Angular component, the Angular compiler is going to generate for you. So if you think about it, the Angular compiler is going to attach these two static fields onto your TypeScript class if you pass this component through the Angular compiler, right? So how about we somehow improve the developer experience by doing just that, by leveraging the Angular compiler in order to actually compile this TypeScript class, so that we don't have to manually type in the theta FAC and the theta CMP static fields on the component class. So that's exactly what I'm doing in the second example. Now, this is almost similar to the first example right here. It's just that I'm not really typing in a lot of this boilerplate code anymore. So I'm not really importing a lot of these IV instructions. I'm just importing three IV instructions here. So one of them is the render component IV instruction, one of them is the compile component IV instruction, and the other one is the mark dirty. I shortly forgot one very minute detail here. How exactly is this component getting rendered? This component is getting rendered because of this call to the render component IV instruction. So to the render component IV instruction, we pass it the component class, or the compiled IV component class, right? I'm saying it compiled because this TypeScript class has these two static fields as well attached to it, right? So without these two static fields, we won't really be able to render this specific code right here. So uh, here we are passing it the IV component, and this IV component class already has those two static fields, and that's why we are able to see this getting rendered over here. Another thing is that I'm supplying a host of IV here. So host IV, and this IV is something that I've also specified in the index.html. So instead of IV, if let's say I change that to host and save, the application will break, right? And so I'll have to make that necessary change over here as well in the host property. And once that is there in place, it should now work as expected, right? So yeah, so one thing that we now have is the render component IV instruction. And then we also have already seen the mark dirty IV instruction. But then this sort of boilerplate that we were writing for the theta FAC and the theta CMP is something that we don't want to do, and so we want to leverage the Angular compiler for that. And so I'll also have to include the Angular compiler as a dependency this time around. So I've added that as well. And with that, I'm doing a very simple thing here. I have this metadata object, and this metadata object might look similar to the sort of metadata object that you pass to the at component decorator, right? So it has a selector property, and then it has a template property, and then this template property has a value which is like an h1 tag, a button tag, and a very simple link. And I'm already passing it to the add component decorator as the metadata, and this already has these two, this property and this method, like the exact same example that we had in the previous one, which is this. It's just that this example right here doesn't have these two static fields like the theta fac and the theta cmp. So this time around, we are going to rely on the compile component iv instruction in order to attach these two static fields onto the iv component class. So that's exactly what this theta compile component iv instruction is going to do. And once that is done, those two static fields, which is the theta fac and theta cmp, will now get attached to the iv component class. And with that, I can then simply call the render component iv instruction, pass it that class with the attached static fields, supply a host, and everything gets sorted. Now, if you also want to actually see if these static fields are applied by the by running the compiler, then you can open this application in a new tab, and then I have also placed breakpoints over here. So one breakpoint is placed before the compilation, and the other breakpoint is placed after the compilation, as you can see right here. Let me just move this down. uh yeah, okay. We can also maybe increase the font size. Yeah, so this console log is before the compilation and this one is after the compilation. Now let's see what happens if I reload the application. So let's reload, and yeah, it first gets stuck on the first breakpoint, which is before the compilation. Now before the compilation, if I type in iv component and press a dot, then you won't really see the theta fac and the theta cmp static fields in there. Now even if I manually type in the theta cmp and press enter, you'll see that it is undefined right now. I can do something similar for theta fac static field. So both of them are undefined right now, right? Now let's step this through, and now the compile component iv instruction has been applied on the iv component class. So now if I type in iv component again, and then type in theta cmp, then I'll see a static field being attached to the iv component. The value of that static field is this object that you see right here. And something similar will happen if I type in theta fac as well. This, right? So now with that, I can just type in my Angular application, my Angular component the way I'm used to typing in right now, and then I can just supply that iv component class to the compile component iv instruction, and also pass it some metadata, and then it will automatically attach those two static fields that are required for Angular runtime in order to render that component and detect changes on that component class at runtime. And then it will also and then once it attaches those two static fields, then I can simply add it to the render component iv instruction. Great. Now these are the two examples that we have seen. Now let's see how it can help us with simplifying the way we render components dynamically at runtime, right? So we'll be seeing another example wherein I will be loading uh, an iv a lazy iv component, for instance, right? So let me just open up the app component.html, and yeah, let's just comment this markup out, and let's uncomment this one. Great. So as you can see here, if I open up the application, then you will see that it renders just a button that says load component lazily via render component. Now uh, clicking on that button calls this method, and this method is present right here, this one. And this is basically doing somewhat similar task as this previous method that we used, right? So in the previous case, we were depending on the resolve on the component factory resolver, and then we were calling the create component and all these specific methods, right? Now it's a bit difficult to remember these methods, first of all, and the second thing is it is also a bit more noisy as compared to the method that I'll be showing you right now. Now, in the stack blitz example that we saw here, we saw that we can just use the render component IV instruction in order to render a component, right? So, what if I just use the render component here as well? So I use the render component here, but I need the component class with those static fields attached to it, right? So I call the dynamic import statement once again, and then I supply the path right here. I destructure out the lazy IV component from there, and then I pass it. Then I pass that to the render component IV instruction, which is something that I've again imported from Angular core. And so with that, let's see what happens. So I click on the button, and then you'll also see a network request that would go on to fetch that IV component lazily, and then so this network request went out, and then it loaded this component. But this time around, we are not really relying on the component factory resolver or the view container ref in order to call those specific methods in order to render the component. This is one great aspect of it. Other great aspect of it is, Stephen, how much time do I have?
I think you have a couple of more minutes, Siddharth. Couple of more minutes, yeah.
Okay, okay, great. So yeah, the second thing that I wanted to highlight quickly is that let's say if you didn't really want a very long name for your selector or your host element, right? So right now I'm using a very long name for the host property to set it, but I can the beauty of this host property is that I can supply basically anything as a value of this host, and by anything I mean literally anything. So let's say that there is a host here. uh, the host is using the selector as anything here, right? So let's say that we can expect that this lazy IV component also expects a host property which is of type string, and then that's exactly something that we are passing it as an argument here as well as here. So now on the UI you will see two buttons. Both these buttons are referring to two separate hosts, right? Another good thing is that if the component is loaded once, then it won't be loaded again, right? So that is also another aspect of it. Now I'm using two different host properties, but I will be able to still render the component with just this one function. I'll just have to specify the host as the host, which is coming in as an argument right here. So let's clear everything out. And as soon as I click on a button, a new request would go on, and it would fetch that lazy IV component on demand. And then since it has already been downloaded, if I click on the second button, a new request won't go. The same component that we have here would be leveraged in order to get it rendered onto the UI. So I click on the button, and then that gets rendered. Great. So far, so good. Now, uh, let's say that I open this component, and inside this component, I wanted to load some data that is coming in from uh, a call to a method that is present or exposed as a part of a service that I have injected as a dependency on this component. So what I mean by that is, let's say that there is a data service that I've injected on this component as a dependency, and then this data service is having a get data method that I'm calling, and then whatever data it is returning to me, I'm just logging it to the console. So let me just click on the button. Now the request went out, and the IV component was also loaded, but I couldn't really see that being rendered onto the UI. But I do see an error as well here. So let's open up this error. Maybe I'll just open it in the console. And it is saying that inject must be called from an injection context. Now it's saying inject, so it definitely has something to do with dependency injection. Now, the problem that we have here is that this specific component is being loaded dynamically at runtime, but then this doesn't really have a context of where exactly should it load a specific dependency from, right? It doesn't really have an injector of sorts. The great thing about the render component IV instruction that we have here is that as an argument, we can also supply to it an injector. I can pass it an injector, and this injector is also something that I can inject as a dependency. So I can do something like injector equals to this dot injector. And if I save this, go back to the application, and let's go to the network tab. Let's clear everything out. I'll click on the button. Now the component gets loaded. Another thing is that you will also see this network request going on to an API that loads in some data. And that data is also something that I've then logged onto the console right here, this one. So I should be able to see that data as well on the console, right? And yeah, so that's great. I have just demonstrated how we can dynamically load a component, and then how we can do things like dependency injection and lifecycle hooks. And lifecycle hooks is also something that can be used. So I'm not sure if I have much time, but yeah, this example does have that thing. So you'll be able to check that out at the end. Where exactly to from here? Well, into a world of Angular, then where you probably might not have to rely on Angular modules just in case you wanted to render a component, maybe, or you also might not have to rely on zones.js for dependency injection, because you have already seen that in this example we are not really importing this mark dirty from zone.js. We are relying on Angular core in order to uh, detect changes, right? So yeah, this is something that might be possible in the near future. Now, a lot of things I couldn't cover today in this session is something that I'll probably cover as a part of my 4 hour session that I'm taking tomorrow. So please do check that out. I'll be sharing a link to this on the slide right here. So yeah, please do check that out. And with that, thank you so much for listening, and you all have a great day ahead.